Today and the next couple days, I want to talk about thermodynamics, which seems the least biological of all the things I'm going to talk about, but it's actually extremely important for understanding how biological things work. It's also the kind of place where there are a million pitfalls. My feeling about thermo is if you think about it sort of and stay on the straight and narrow, you get it, you understand it, you're fine. But if you stray off the path, it's really easy to get very confused and think about things the wrong way. And there's lots of traps for the unwary. So I want to make sure I get this business clear today, and that's what the snap bracelets are partly about, is to understand how this business works. So let's take it piece by piece. So the reason we care about this is the major goal of living things is controlling chemical reactions. In fact, you could almost define life as a set of carefully controlled chemical reactions. As an example, I want to digest my lunch to monomers. That is, if you remember from way back when we talked about you are what you eat, so you have your lunch, a cheese sandwich or whatever, you are not a cheese sandwich, but you contain the same amino acids as a cheese sandwich. You have to break it down to amino acids and then reassemble it into you. The thing is, there are two issues. One of them is that I do not want to digest my lunch all the way down to atoms. I don't want to blow it up into little tiny pieces. I want to make it into useful pieces. That's one task. And that is, so cells want to control which reactions happen. Okay. And number two, I want this to happen sometime soon. That is, I want to have my lunch, my breakfast digested by sort of late morning, my lunch digested by early afternoon, so I got some energy and I'm ready to go and pieces to make more of me. So the other thing that you care about, not just which reactions happen, but the other question is how fast. Need to control how fast they happen. So controlling which reactions happen and how fast they happen are extremely important for every living thing. Right? You would not be here today if your body couldn't have unbelievably exquisite control over exactly which reactions happen and how fast. So like in the prototypical example is digesting your lunch. You want to digest, you just want to break the peptide bonds. No other bonds. Just break the peptide bonds. And you want to do it quick so that you can get use of lunch sometime today. All right. So what I wanted is, to understand that, there's a bunch of things you got to know. There's a bunch of important ideas. And there's one, I'll call it an illustrative example. And that is the SLAP bracelets. Right, or SNAP, depending on how you want to call them. And I want to define one thing. This triangle symbol we'll see a lot. This is read as delta. And it means change in. So delta whatever is a change in it. Delta my bank account is a change in my bank account. All right. Fair enough. What I want to do, you may have seen diagrams like this before, you may not, but I want to take you through one of these. There are two states of this snap bracelet that we're going to care about at first. One of them I'm going to draw out like this, the straight state. And then there's the coily state, the coiled. Right? And you probably all saw them. So this is the straight state, right? And you can transform it reversibly between the coiled state and the straight state. Right? So we want to talk about this from a thermodynamic point of view. So I hope everybody had a chance to snap it and slap it and check it and see what was going on with it. And I want to draw a diagram here. Let me even give myself a little more space. This is going to be from high to low, and this is PE, that is potential energy in the bracelet. Okay? And this is and down the bottom axis here, and this is where one of the many places people group up. These are different states of the bracelet. So what I want to do is I want to put on this graph, on this chart really, it's not so much of a graph as it is a chart, different states. I'm going to have the coiled one over here and the straight one over on this side. And I want to know their potential energy. Not exactly the difference, but which one's higher? Are they the same potential energy? Is one higher? Is one lower? If they're different, which one's got the high potential energy? And again, to be really clear, the potential energy in the bracelet. Right? So is this the high potential energy state, or is that the high potential energy state? And really importantly, why? So it's one of the things, talk to your neighbor, argue about it, we'll call names. Which is the high potential energy state, straight or curly?